Hello, everybody. We are back. We continue the WLAN technology, how it is working. We are talking about WLANs and how the WLANs are working. We talk about in the first session, we talk about how the access point are communicating with client devices, and also how client devices are asking for communication from the access point. And we talk about the heartbeats, which we call it beacons. The beacons are sent all around the place from the access point to declare its presence. So anybody or any client device in the neighborhood can join the access point. Here we talk about the technology. Actually, we talk about the types of antenna. So we have a wireless antennas. Where they have three different types. The first one is omnidirectional type, and the semi-directional type, and directed type. Directed. So I'll talk about this one here, the highly directional one. Okay. Let's get back to the omnidirectional one. This is the general purpose antenna typically installed on any web. This is the most general one. It is used to distribute radio frequency all around the place in an in all directions equally, and providing 360 degrees of coverage. So its coverage is a circle. Its coverage is a circle. The omnidirectional is has a circle coverage and the access point in the middle of this circle, or on the center of this circle. For the semi-directional, it is not actual. It is something between highly direction and omnidirectional. It is not having 300 degrees coverage, but it has 100-degree coverage. 100-degree coverage is like the human eyes, exactly. So if you see the human eyes, they are seeing in front. You are seeing in front of you, to the right and to the left, but you cannot see your back. Here, semi-directional direction is the same thing. So it covers in front of it. It has a direction. So it covers the direction in front of the access point. But the back is very weak signal. The front is very strong signal. The back is very weak signal. So this is 100-degree coverage. 180, sorry. 180 degree coverage. Okay, excuse me just a second. Here, this is a semi-directional, they call it Yagi antenna. Because if you see this here, this bar here is just like an arrow, the direction to the right, direction of these radio frequency, radio waves is directed to the right hand side. The left hand side, no signal, or the signal is very weak. This is semi-directional antenna. Here also another type is called planar antenna, and planar antenna also has the semi-directional capability, so it can direct to specific place, not omnidirectional, which distribute all the signals around the place in 360 degrees. Here, the higher directional antenna, just like a flashlight, is like a flashlight or beam of light. Exactly. Very focused beam. And even it behaves like light. So if a barrier in front of it, maybe it will not be able to communicate. if you see the the antenna for television, the dish, the big dish that you install on roof of your house to get the signal, the television signal. This is highly directional antenna because you are directed the one or the installer of it direct it toward the satellite. And as you know, maybe this is very important for you to understand. I will try to wake you up, okay? To fresh you up right now. I will ask you a question. If you answer this question, I know that you have a background about wireless communication, okay? Okay, okay. Concentrate with me. Now, by the way, I get to the account and now I succeed to record the lecture and also annotate. So this is after a huge challenge to find the settings. Yes.
Thank you,
Now
doctor.
yeah,
Thank you, Doctor.
yes, I came to the account. I get delve into the account. I found many options, and then I found it is in between lines like that. So now is okay. I can now I start this lecture is recorded. This lecture, this session, not the previous session. This one. Now I can annotate. I can do anything right now. Okay, let's concentrate. If you answer this question, you are clever. Look at me. This is my house. Okay, and this is my door, and this is my window. Okay. Now I'm sitting in first floor. Okay, but anyway, I at the beginning of stay here at the house, I like to watch TV like everybody else, but actually I don't have time for that. Anyway, my child like to watch TV, so installed the big screen here and communicate. Okay, let's change the color. I'm happy that I can change everything here. So here the line and the line to the satellite dish. This one, I don't know if you know it or not. This one, I hope you understand that. And the guy, the boy who came to install it, directed it to the satellite. And I know, let us talk about the satellite is here, and this is the satellite. I'm not good at drawing, but anyway, I'm trying to imitate something like that. This is the satellite, okay? And it's highly directional. The question is, concentrate with me. The question is, satellite is revolving around the Earth. How it is highly directional, and at the same time, the satellite is revolving around the Earth. It is moving, is not fixed. The question is why? Why is that? Why the guy is fixing my satellite toward this, sorry, fixing my antenna toward the satellite. And at the same time, I know it is moving. The satellite is moving around Earth, is not stable, is not fixed. Do you know why? Do you know the reason behind this? Anybody knows?
Um,
First, you understand the question?
yes, doctor. Yes.
Yes. All dishes on all houses. If you have a higher building, you jump over that higher building and look at all houses. You will find all dishes directed to the same direction, which is the satellite. It is insane because the satellite is not fixed, it's moving. Can anybody tell me the secret behind this?
maybe it have something to do with signals.
Not actually. It's good trial, but not actually.
Uh,
Abdullah Ahmed, thank you for your activity, and I want others to share us.
welcome, doctor. Thank you.
Abdullah Isam, where are you today?
Uh,
Shay,
Doctor, I can't know the answer for the question.
you can't understand the question?
No, 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 doctor. It's doctor. The thing is that I have just an exam today, so I can just focus on the class like hundred
Okay,
percent. I
okay, no
focus, yeah, but
problem.
I'm sleeping.
It's
I
okay, no
don't
problem.
know.
Ferial, you have any Ferial? Are you there? Ferial, Nadine.
Yes, doctor.
Yes, Ferial. Do you know the secret behind my question? If you, I can repeat the question again if you didn't listen to it. Nadine, do you have any Hagar? Anybody else? Haneen Ali, Haneen Yusuf, Muhammad Ramzi, Nurhan.
دكتور
Where are?
عشان يمكن القنوات.
Mm, still not actually.
Radio waves.
Yeah, radio. Yeah, it's not. It's not radio wave. It's microwave. Yes, using highly directional Nurhan. Yeah, it's highly directional. So it's like a beam of light. It's not radio wave. It's not. It's radio wave, but it's high frequency. It's very high frequency. And if you increase frequency, the signal is not passing through barriers. So you have to make it very highly directional. Okay, let me answer this question. This question is about you can say gravity and Newton laws, something like that. You know that the Earth itself is revolving around itself about 40 kilometer per second. This is very high speed. Okay, 40 kilometers, actually not per second, per hour. Sorry, it's not that fast. 40 kilometers per hour. Okay, the Earth. This is Earth. Okay. Now I put the satellite on an orbit, not far away, not too near, something that makes it revolve at the same speed, which is 40 kilometers per hour. So you know about Newton laws, relative speed. The relative speed between, because they are moving at the same speed. So the relative speed is zero because they're moving the same speed. The satellite and the Earth is revolving around with the same speed. So it seems like the satellite is actually rotating around Earth, but it's fixed because it is rotating with the same speed of Earth. You understand? So if you have you and your friend traveling around the place, traveling with your cars, two cars. This is his car. This is your car. This is not a car. It's like a shoes. Okay, so this is two cars here, and he want to give you something. He is he is speeding up with the same speed of yours, so you can talk to each other. And even if you want to give him something, you are able to give him. Just like your speed is high, but your relative speed is zero. You are fixed to each other. It's because you are talking to each other, and he's going to give you something from the window, and you take it from him like that. So this is why the satellite, this is why the antenna of television is directed toward satellite, and satellite is revolving with the same speed of Earth. Okay, now you understand the solution. Anybody can tell me the solution again?
Doctor, the
Yes.
satellite is moving as the same speed of the Earth. So basically, it's zero.
Yeah,
Uh,
relative speed is zero. Yes.
Relative speed is zero. So that's why it's pointed to the satellite, and satellite is moving around the Earth.
Yes. Thank you. Thank you, Abdullah. Thank you.
But doctor,
Yes.
the drawing is very bad.
The draw. Yeah, yes, I know. I'm trying to learn some drawing with my child.
No, doctor, I'm joking. I'm joking.
Yes.
Okay.
For yes, actually, my drawing is good, but not with mouse. Is
آه.
with yes. I can try that. No problem.
No دكتور صح عندك حق دكتور mouse is
Yes.
hard.
Yeah, mouse is hard to draw. But you see, I have a sketch of my house and the antenna. This is good. I'm now advanced. Yes. Okay, so the highly directional, as I told you, it is point-to-point communication, and the communication is done through a very focused beam. It's like beam of light. So if any barrier in the face of this or cutting this beam, the communication is cut. The highly directional problem is this problem. Is just that if some barriers, it will cut the signal directly. Is not like radio waves. Radio waves or the high frequency or the low frequency radio waves, which you are listening to our radio stations, they having very low frequency. The very low frequency can pass through objects. So you stay at your car and you are delving between mountains in the road, and you can even listen to the radio station. Maybe sometimes it's weak signal, but it's acceptable. But for the highly directional, no, nothing like that is happening, because if any barrier of any type stand in that flashlight beam, it will cut the signal directly. Okay, so this is the highly directional, like this one. This is a highly directional antenna. It is similar to the one that we use uh, for television. And here, this is highly directional. They call it parabolic antenna. This one we use it in our television. Okay, so the signal is coming from the satellite, okay, and I want to tell you something. Why this dish is there? Just this is very simple. Maybe you know about it. The signal is coming and bouncing from here, and they are coming to this led or this lens. They call it lens or something. I'm not good at that, the name of these parts. But anyway, the idea is the signals are hitting this dish and then bouncing back to that place. All the signals doing the same, bouncing to the same place. This is the design of the parabolic dish. The design is to have all bouncing coming to one point, which is this point. All bouncing reflected back to this point. So the signal is coming very strong, and because it comes from all directions, so it comes very strong, and it can be transferred to the television to display the multimedia. And that's the high directional antenna. And also we have here, the W or WAP or wireless access and wireless access point is half duplex. Half duplex. You know about half duplex and full duplex?
Doctor,
Half,
it's maybe of the speed.
yeah, the half duplex and full duplex. Yes, the speed of half duplex is lower than the full duplex.
Latency.
Yeah, but it has an idea. It's like,
The transmission between the sender and receiver.
yeah,
Who sends and receive half duplex only send from the station to the receiver. Full duplex, both of them are sending
yeah,
the
Hagar,
station and
thank
the
you.
receiver.
Yeah, you study
Thank you.
very hard, Hagar. Thank you. Uh, so the half duplex is just one-way transmission. If you send, you cannot receive. This is half duplex. But for the full duplex, you can send and receive at the same time. So this is access point actually working on the half duplex transmission, not full duplex transmission. But if it has this type of antenna, it can have the full duplex capability. Okay, I disable annotation. You start to play around. Okay, so this is, this type
Doctor,
of
it's me by
antenna.
mistake. Okay.
No problem. It's okay. No problem. No problem. Yeah, so we have here this type of antenna. You can say this is full duplex because this these terminals, one for sending and one for receiving. This is the MIMO, multiple input, multiple output antennas. So it has multiple input and multiple output, and it can use the full duplex capability. So it has more faster speed, as you say, Abdullah Assam. So it is more faster. The full duplex is more faster than half duplex, because in half duplex you have to wait for the other one to receive from her from its side or send to its side. So the very important aspect, if we talk about security here, we always talk about security. We are concerned. Why we study all of this? We are not radio engineers actually. We are security engineers, and you have to pay attention always to this. Why we study antenna and why we study the directions and the coverage maps? Just because the coverage map is important because the signal is there. If you don't know the coverage map, the hacker can go to the place that he knows that there is a signal and try to fake people. Fake people by what? Just planting a fake access point in that range with the same name, and the employees will be faked, and uh, they can be breached easily. So here you see this is for omnidirectional antennas. The omnidirectional antennas, as I told you, it is in the center, and the signal is distributed 360 degrees around the place. So the antenna is in the middle. This is iBird projection. This is somebody looking from the sky. This is the access point in the middle, and I'm looking from the sky to the area. This is what you see. This is the coverage map of the access point in omnidirectional coverage. Here, if you look in to the access point and the access point in front of you, if it is in front of your face, you're seeing it. So this is the coverage map. This is its coverage map. This is up and down coverage map. This is a sector of the circle. Okay. So this is up and down and right and left. Up and down and right and left. Okay. So up is not too much. Down is also too much. To the right is too much. To the left is too much. And also, to to the front is too much, and to the back also is too much. If you can imagine this one, you are standing here in the middle, and I can see your head as a circle. But if you stand here, I can see the full body, full of your body. You are standing in the center. So this shows the up and down or the vertical direction, and this is showing the horizontal direction. Now you can understand the coverage map carefully, and you can design your antenna or access points to locate the access point in a good design. I mean, I will tell you about that in the next slides, that you have to plan the locations of the access point according to the coverage map. Now here we come to the semi-directional coverage. The semi-directional coverage is here. This is the horizontal one, and here is the vertical one. This is the horizontal one, and this is the vertical one. Actually, you see here, this is in front of the of this is in front of the antenna, and this is to the right of the antenna. So you take care of this because the coverage map is important, as I told you, to have to discuss or to study the overlapping between the signals from different access points. So this is a semi-directional coverage map, okay? And here we go to the activity, and I want all of you to share me solving this activity. Omnidirectional antenna. Which one is omnidirectional antenna? Antenna designed to transmit and receive with greater effectiveness in particular direction, most of the often at the expense of all other directions. This is highly direction, right? This is highly direction. What about this one? Technology that allows multiple antennas to transmit and receive concurrently.
multiple doctor.
Yeah,
Multiple input.
MIMO. Yes, this is a MIMO. Multiple input, multiple output. What about the antenna that transmit and receive signals in all directions?
Semi.
Omi.
Semi.
Omni.
Omnidirectional, yes, exactly.
And
Who
the
said
last one,
omnidirectional is okay? The last one is difficult because we cannot answer it. This is very
no,
easy.
doctor, you said it's only in a single direction, so it's a semi.
Yeah, doctor. Here, omni means single, or
No, no,
No,
omni,
semi.
omni is not single.
Semi is single. As you was reading through the slides, you told us semi is single. So
No, semi is not actually is not single direction. It's something between omnidirectional and highly directional. So
okay.
something between highly direction and omnidirectional. Omnidirectional in all directional, in all directions. Omni is in all direction. Highly is one direction and a very specific direction. And here comes the something between them. Semi-direction. Is not highly direction, is not omnidirection. So let me revise with you. Maybe I have a mistake. So antenna that transmit and receive signals in all directions. This is correct. This is omnidirection. And for directional antennas that radiate greater power in a single direction. Greater power in a single direction. Let's compare it with the answer for the highly directional. This is maybe confusing. So let's see if this is correct or not. Let's concentrate on this and that one. Antenna designed to transmit and receive with greater effectiveness in particular direction, most often at the expense of all other directions. Yeah, and directional antenna that radiate greater power in a single direction. I think this is correct because this is paying to so it expenses some power in other direction, but the greater power in one direction. This is semi-directional. Okay, so it has power. It is saying it radiates greater power in a single direction. This means it has a power in other directions, but the greater power in a single direction. Here, receive a greater effectiveness in a particular direction, just just a particular direction. So it doesn't care about the other directions. So this is a highly direction. Okay, let me see the model answer. You confused me really. It's okay, but this is, I think this is good. This is true. Let me see. This is the model answer as well. Okay, omni in all directions. That's semi at the expense of other directions, right? Highly, highly is a directional antenna that radiate greater power. Yes, you are right. Okay, this is confusing really. So yes, so I will not give you an example like this in the quiz.
Yes,
Uh,
yes, doctor. We don't want confusing in a
yes,
quiz.
I know. So if it confuses me, so that actually it will confuse you too. So this is okay. Let's solve it again. Omnidirectional is in all direction. So this one goes to that one, and semi-directional is that radiate greater power in a single direction, or that one here, and the highly directional is that one, and memo here. This is the correct solution. Okay, this is the model answer. Okay, so let's move to the other slides. Annotation clear. Okay, so site surveys. That's what I'm talking about when we talk about the coverage maps. So it used to determine how RF radiation will behave within a facility. You have the,
Doctor,
yes,
please, before this slide, explain what's the coverage map function again.
the coverage map. Which one?
The previous slides.
This one? You didn't attend this part?
This one. No, no, I attended, but I want to know only the function,
Yeah,
not this one.
yeah, the function of the coverage maps.
Yes.
Yes, the coverage map is just even in some devices, the access point, when you buy an access point from any website, you will take the access point with a coverage map. The coverage map is important because it defines the signal, the access point signal, the place or the coverage of the access point signal. This is important in what? This is important because if you are designing a network and you want to find the places that you will put your access point. For example, if you want to cover the entire building, maybe one access point is not okay. How did you know that? This from the coverage map. You know that the coverage map, for example, covers omnidirectional 100 meter. So if you want to cover more than 100 meters, you have to think about two access points. So this is why there is a coverage map. A coverage map is important to design your access point, and also in security, because if you don't know your coverage map, maybe you think that, for example, you are covering 100 meters and your building is just 700 meter by 700 meter. So you know your signal is traveling to a very long place, and your signal is captured by attackers, and you don't know about it. So that's why you have to study very carefully the coverage map. Okay.
Okay, doctor, thank you.
Okay, welcome. So the site surveys. That's why there is a coverage map. The coverage map helps us to determine the design of our access point locations, we do site survey. Survey is to determine how RF radiation will behave within a facility. So you take into your account the coverage maps, the inferences from other signals, and the gaps between the antenna placement and the power consideration. The gaps means if you are covering with circular antennas, circular coverage maps, you have to make overlap between them to be able to cover the exact place or the exact surface. If you talk about a building or something, you have to cover it with some overlapping, no semi-overlapping, not complete overlapping, just semi-overlapping to make sure that you know about the circles. Here, if we talk about circles, maybe you are giving access point here and another access point here. So if somebody is in this place, he will never get a signal either from this access point or that access point. So you have to make it like overlapping, not overlapping actually, just semi-overlapping, to have the same effect of the cellular design that we talk about. Something like that. Okay. So you do it like overlapping to make sure that it's covering all the places. So the site survey is helping us to find the locations of the access point and to define the interference between different signals. So for the site survey process, it varies greatly in its complexity. For example, some sites are having multiple interference from other sources of radio waves. So maybe the place is clean, there is no signals, and the place has interference, and you have to study this interference carefully. Okay, let's move to the next slide, I think. So the spectrum analysis, this one is very important, and you need some device to help you define the spectrum analysis or the frequencies. You measure the frequencies in place, the frequency signal, the frequency power, the frequency, the signal frequency, the signal power. So you have to study all of them using the spectrum analyzer. The spectrum analyzer is a device that measures the amplitude and frequency of the electromagnetic wave signals or radio waves. So you have to use this spectrum analyzer to measure the amplitude and frequency of the electromagnetic waves. Without this device, you will not be able to make a site site survey. Without the spectrum analyzer, you will not be able to make site survey. Okay, so you do a spectrum analyzer to visualize and map what RF activity already existed within the 2.4 and 5 gigahertz per second spectrums, because we are using those two spectrums in our access point communication. As I told you, this is unlicensed frequencies. There is no license from them, and access points are working on those two bands. So you have to just use the spectrum analyzer to find if any signals are coming from 2.4 and 5 bands or not. If you find something like that, maybe you can reconfigure your access point to work on different band or different channel on the same band. Okay, so if a background noise unwanted radiation on those channels exceeded 85 decibels, wireless network performance suffers. For example, if you are working in a specific channel and you find another access point working on the same channel with a noise more than 85 percentage or 85 decibels, this is going to affect your performance. This is going to affect the performance of your network. So what are the sources of noise? The microwave ovens, because the microwave ovens working on microwave, and these microwaves are used in communication. The cordless phones, and this is the cordless phones. I see it maybe in army or for security purposes. The cordless phones, fluorescent bulbs. The fluorescent bulbs also emit some frequency that or some signals that may affect the performance. The elevator motors, the Bluetooth radios, other 800 to 11 wireless networks. And this is actually is not going to affect, essentially not going to affect the performance of your network, because there is some kind of technology that spread the spectrum, which is not specific to a channel. It jumps from channel to other. So maybe this is not going to affect your performance, but the other sources of radio performance, radio waves is going to affect your performance or the performance of your network. And also the last one, which is the most important one, the malicious transmitters or jammers. What are the malicious transmitters here? It means a hacker with an antenna sending on the same band, on the same channel, with a very strong signal. And I told you, if very strong signal in place, there is no way the other weak signals can send and receive. This is jammer. Jammers means I take the entire band for myself. I will not any other frequency wave to pass from the sender to the receiver. This is an attack. This is just an attack. This is some kind of device with the hacker, and he sends and receives with very strong signal and not letting any access point in neighborhood be able to send or receive. So if you want if you go to the company site for the first time, you have to think about the coverage map and conduct a site survey, just using interviews. For example, conduct site coverage and capacity planning interviews. The interviews is very important. Interviews are very important just because you are new in the place, and maybe it will. I mean, you will not need to do extra work because it is known from the previous employees or from the previous workers on this place. So surveys will not let you take more time to make a site survey. You will make it faster if you make good interviews. And also information gathering exercises to establish the capacity and the coverage requirement based on the population density in certain areas. So some places, for example, in the company, some places has density, people density more than others. So maybe you can increase the number of access points in a place and decrease the number of access points in another place. Okay. And also no special tools are required. You can also you can even use your computer laptop to measure the frequency or to check the existence of the signal or not. You can even don't you don't need to buy the spectrum analyzer. That just for small scale company, no need for a spectrum analyzer, because if it is not working, so you have a problem in interference between signals. Even you will not, you will use your laptop to make a site survey for the signals, just to reduce expenses. Uh, so survey dictates location and boundaries of access point. If you don't have good site survey, you will not be able to locate the good positions for each access point. The position must be checked to ensure it's within the reach of wiring closet. It within the reach of wiring closet, because you know, um, it's a bridge between the LAN, the wireless LAN, and the access, the wireless clients. So if you make the access point very far away from the wired LAN, you will decrease the signal. Sorry, to decrease the strength of the signal, because you know you are limited in the cable or Cat5 cable into 100 meters. So it is better to make the access point very near to the wired LAN, and use a mixture of omnidirectional and semi-directional antennas. And after access points are placed and enabled, assess the coverage manually or through the use of predictive analysis. Okay, you can do that actually manually. Okay, to see the coverage map after installation. I mean, after installation, you have to think about the coverage map. That's why it's important to make the site surveys two times: one before installing your wireless LAN and after installing it, to make sure it's working and there is no interference. Okay. And for the manual methods, we have two types or two methods: the passive method or the passive mode and the active mode. In the passive mode, the client card is used to collect the RF measurement of received signal, noise, and signal to noise ratio. This is just your laptop is used to do all the job. For the active mode, the client station authenticates and associate with access point. This is, we said about that, it is the kind of communication between the access point and the client or the wireless client. We talked about this already. I think this is a repetition of the same concept: passive mode and active mode. And also you can use predictive modeling application. This is very important. It's going to help you, just like, for example, uh, packet tracer. Packet tracer, I don't know if it has, I didn't try it, if it has coverage map or not. But for the time being, I worked a long time with packet tracer, but really I didn't see anything about coverage map. Maybe the new version of packet tracer will have this ability, but or functionality. But for now, for the version that I'm working with, there is no thing about coverage maps. So it's like simulation and modeling means that you install, actually go to the site and install the access point. You will find that problem, then you try to solve it, then install it again, and then find a problem, and then solve it again, and then install again, and so on. This is an endless cycle, but it is better to use software just to make sure that everything is okay before going to the site and install your access points. That's why the predictive modeling and simulation application is important for you, just to save some time. And that's all for today's lecture. If you have any problem, any question. Now yes, any question?
No, doctor, thank you.
دكتور
Yes.
نبى نعرف اللي داخل في امتحان.
اللي داخل في
دكتور
الامتحان. Yes.
إيه؟ إنه مش no paper أو pen فإزاي ممكن تقول لنا how we will handle everything؟
No paper and pen. Just write down the answer. Just write down the answer for cryptography and for this one, for the wireless security. So just
But
write.
doctor we can solve
You can't what?
we can